The world we live in is full of life of various different sizes, from bacteria that are only micrometers in length to others like the blue whale, which can reach up to 100 feet and weigh more than 150 tons. This knowledge is only based on what we have discovered so far, and if we were to analyze more of the world, we might be able to find even bigger creatures. In fact, if we look beyond our own planet and found a smaller one, there is a chance the creatures there are much larger. This is because smaller planets, in particular, have a lower gravity, one of the key limiting factors to size. But before analyzing the size of life for other planets, let's briefly establish what Earth has to offer. Some of the largest creatures in history were from tens of millions of years ago, when creatures like the Titanoboa and Titanosaur roamed through their corresponding habitats and dominated any that got in their way. In present times though, the largest land animal is the African elephant, still relatively large. This animal stands at about 13 feet in height and 24 feet in length, and weighs about 7 tons. However, compared to the extinct Titanosaur, specifically the Patagotitan, the African elephant can't even be recognized, as this humongous creature stood at a length of 120 feet and weighed 70 tons. In fact, scientists think this is the largest land animal not only discovered, but also the largest possible size a land animal could get. As mentioned earlier, this mainly comes from gravity, which puts strain once an animal becomes too large. To demonstrate, let's take the square and compare it to double its size. This would cause the bigger square to have 4 times the surface area, as you could tell by the amount of squares inside. But at the same time, the volume would increase by times 8, as you could tell by the amount of cubes inside. This would cause a very uneven ratio in size to volume, and as a result, if an animal is too large, its volume, and therefore weight, will be too much for its size. This will make it extremely difficult for the muscles and bones to support it. But in the ocean, all of that changes. Gravity is no longer the determining factor, but rather food. This is because the bigger the animal, the more food it needs, and since there's limited food, it can be very difficult for an animal to obtain. However, the main focus of this video will not be on ocean creatures, but rather land creatures, and more importantly, some of the largest forms of life we might find within our universe. Planets in particular have many factors that determine what kind of life can exist, such as the subduction processes, sunlight, water, and much more. On Earth, the main force is gravity, but for smaller planets, others like the atmosphere and energy content can also influence how big life can get, because big animals do need lots of food and energy. But for simplicity's sake, we will mainly talk about the effects gravity can have on size. To start off, let's examine the size capability of organisms on a planet with 50% of Earth's mass. So far, there hasn't been any discovered planet that is around that mass, but assuming it exists within the billions of other planets in our galaxy, it would look this big when compared to Earth. At first glance, it wouldn't look right, but it makes sense when going back to the volume to size ratio concept. In addition to its smaller size though, if this planet were to have a slightly smaller density due to a different core, its gravity would be about 7.4 meters per second squared, give or take, or in other words, 80% of Earth's mass. Although not too far from Earth's gravity, it would definitely be a noticeable difference for us. Everything would feel 25% lighter, and the environment would definitely be a bit different. Assuming we were able to evolve to make its gravity feel the same, we would be about 7% taller and 25% heavier. This means that if you were 6 feet on Earth, you would be about 6'5" here, which is a very noticeable difference when compared side by side. On the other hand, an animal like the African elephant would be 14 feet in height and 25.5 feet in length. Although noticeable, these differences wouldn't really be that significant. However, all of that changes once we move on to even smaller planets. To demonstrate, let's analyze what life could look like on a planet like Mars. A planet not too far from Earth, Mars is currently too cold to hold life, but within a billion years or so, when the sun grows in size, Mars might become just like Earth, placing the planet in the new habitable zone. This could allow the planet to sustain the same kind of life Earth does, but at a different scale of course. The planet is about 10% Earth's mass and has a gravity of approximately 3.72 meters per second squared. This would be equivalent to about 37% of Earth's gravity, meaning that life would have to be about 2.6 times heavier, and therefore 38% larger. In other words, it would be like comparing a 6-foot human to an 8.5-foot human. If the same effect were to be applied to an African elephant, it would look like this, at an incredible 33 feet in length and 18 feet in height. The titanosaur, on the other hand, would look even deadlier, at an incomprehensible 166 feet in length and weight of about 180 tons, surpassing the weight of the blue whale. Transporting an animal of this size to Earth would allow it to destroy anything that stands in its way, squishing humans as if they were bugs, and breaking trees as if they were sticks. However, because the surface area of these animals would increase less than its weight, these very large animals would look much different, likely having more breathing entrances. Armored plates might even form to prevent any fall damage. Slower metabolisms would likely persist because their cells would need to release less heat to keep the right body temperature. But moving on, if you were surprised by how big the previously mentioned creatures can get, you won't be able to fathom the size of the creatures the next planet can hold. To show what is meant by this, a planet similar but slightly heavier than Jupiter's moon Ganymede will be used. At that size, it would be equivalent to about 2.7% of Earth's mass, and would look this big when compared to Earth. It is hard to say what its gravity would be because its density can vary by a lot, but for simplicity's sake, let's just say it has a gravity of around 2 meters per second squared, or about 20% that of Earth's. This would mean that the weight of animals here could be up to 5 times that of what's on Earth, making the overall size about 1.7 times more. At that point, humans would look much larger, ranging from 9.5 to 10 feet in height, and looking close in height to the humanoids from Pandora in the movie Avatar. Lots of insects would likely be as large as small rodents, with insects like tarantulas being even bigger than your head. It wouldn't be a pleasant surprise to have just one of these devouring your body. In the meantime though, you can expect elephants to reach a whopping 22 feet in height and 41 feet in length, causing a weight of about 35 tons. However, the size of elephants wouldn't be our biggest concern if we consider some of the larger animals that are now extinct. For example, the scorpion species Pulmonoscorpius could grow up to 2.3 feet on Earth, which is already very big as it is. On a planet the mass of Ganymede though, it would grow up to 3.9 feet. A scorpion this large would probably be enough to instantly rip you into pieces, let alone a pack of these just roaming around. What would look crazier, however, is the Josephorotogacea monesi, the former extinct rat-like creature that's normally the size of a car, instead being the size of a van, and weighing an enormous 5 tons. The Titanoboa, the extinct snake mentioned at the beginning, would on the other hand grow up to 77 feet in length and weigh a tremendous 8 tons. This would allow it to basically swallow multiple people at once, and wouldn't be a pleasant sight of landing upon. But still, nothing beats the size of the Titanosaur, which would grow to a mind-boggling size of 204 feet in length and weigh 350 tons. That weight would be equivalent to more than 2 blue whales. To truly show how massive a creature like that is, this is the size of the African elephant, the largest land animal on Earth, which looks like nothing in size next to the Patagotitan. For further comparison, this is how the giant sequoia would look like, the tallest tree species in the world, which averages around 300 feet. On the other hand, this is what a typical New York skyscraper would look like, at around 450 feet. To truly understand the size of these things, this is what a sequoia tree would look like from a human's perspective, a tree that would be difficult to completely see. As for a 400-foot skyscraper, if you were to look down from that kind of height, you would get a view similar to this. A creature this large would probably require military helicopters and tanks to take it down. Although beyond impressive, it is important to know that a creature that big would be very rare, even on a small planet, as it would have to devour too much food and probably only survive under a very specific environment. A planet of this size would also very likely be the limit to what it takes to hold life. This is because if it were any smaller, the planet's core would lose too much energy due to the large surface area, and gravity would be too weak to contain an atmosphere, meaning essential gases like carbon dioxide and oxygen would be able to escape the atmosphere, and the remaining water would likely freeze. In fact, it should be known that it would probably be a rare sight to see a planet this small with life equivalent to that of Earth's. However, despite these general predictions, as mentioned before, it is unknown what kind of life the planets mentioned in the examples would truly have. Additionally, smaller planets could better hold an atmosphere if given a larger density, allowing for a higher escape velocity while still retaining a lower gravity. And it is certainly not impossible for small planets to hold lots of giant life, especially with certain exceptions to some planets. For example, Jupiter's moon Io is the most volcanically active body in our solar system because of the gravitational tug between the planet and the other moons. Meanwhile, Saturn's moon Titan, which is also really small, has maintained an atmosphere even thicker than Earth's because of the materials it received from the comets mixed with a warm interior. On top of that, we've seen creatures on Earth that have evolved to the most extreme circumstances you could think of. The universe, let alone our galaxy, is full of extremely strange planets, stars, and other cosmic bodies, meaning that the corresponding forms of life could only be even bigger and stranger if we look hard enough. Thank you for watching this video, and please consider liking and subscribing to this channel for more informative videos. Until then, stay tuned.